If you've spent any time at all around network engineers, you've heard the joke. Something breaks, everyone's stumped, and then someone just sighs and says, it's always DNS. And it's funny because it is so often painfully true. DNS is this invisible foundation for pretty much everything we do online and in the cloud. And when it gets a little wobbly, everything comes crashing down. So why is it so notoriously tricky? Well, that's what we're here to figure out. All right, so let's dive right in and pull back the curtain on one of the most critical yet misunderstood parts of your cloud, private DNS. Now, we're not just going to click through a tutorial here. We're going to get to the story behind it, starting from the very first principles. The goal here is simple. By the end of this, you won't just know how to build it, you'll actually understand it. And that means you'll know how to fix it when, not if, things go sideways.
So, here's our game plan. First, we're going to start with the philosophy, the big why of it all. Then we'll talk about creating a private reality, this idea I call the split. After that, it's time to get our hands dirty in the lab and build our very own private phone book. And then, my favorite part, the sabotage, where we are going to intentionally walk right into a classic DNS trap just so you can see exactly why it drives people so crazy.
All right, section 1, the philosophy. Now, I know, but trust me on this, this is the most important part. If you really truly get the why behind DNS, all the technical stuff that comes later, it's all just going to click right into place. I promise. Okay, think about it like this. There's a huge difference between someone's identity, who they are, and their location, where they are, right? The president is an identity. It's a role. The White House, well, that's just a location, a temporary address. They are not the same thing. Well, it's the exact same for our servers. A server's identity is its job, its role, like our production database, db.prod. Its location is just an IP address, like 10.128.0.5, and that address can, and probably will, change over time. And this, right here, brings us to the absolute genius first principle of DNS. It is a system, a layer of what we call indirection, that completely separates the identity from the location. So what does that really mean for us? It means we can pick up our database server, move it to a totally new virtual network, give it a brand new IP address, and our application doesn't have to change one bit. It just keeps asking for db.prod, and DNS handles the rest. See, if you ever hard code an IP address into your application code, you have broken this sacred principle, and you are just setting yourself up for a world of pain down the road.
Okay, that makes sense, right? So let's build on that idea. Section 2, the split. This is where we use a concept called split horizon DNS to basically create a separate private reality that only exists for our network. This is where it gets really cool.
So picture this. Someone's out there on the public internet, maybe at a coffee shop, and they try to find your secret internal server, maybe something called internal.corp. They ask a public DNS server, like Google's, hey, where's this thing? The answer they get back is simple. Sorry, never heard of it. Doesn't exist. To the rest of the world, your internal network is a complete ghost. It's invisible.
But inside your private cloud network, it's a completely different story, a different reality. When one of your own servers asks that exact same question, your private DNS server chimes in and says, oh, internal.corp? Yeah, I know that guy. He's right over here at this private 10 dot address. This split reality isn't just a neat trick. It's a fundamental security layer that hides your entire internal world from prying eyes.
All right, enough theory. Theory's great, but let's actually build something. It's time for Section 3, the lab. We're going to take these principles and put them into practice to build our own private phone book in the cloud. Now, the logic here is actually really, really simple. First, you need a target, right? So we'll spin up a virtual machine to be our database. Second, we need the phone book itself. In the cloud, this is called a private zone, and we'll create one for our domain, internal.corp. Third, we add an entry to the phone book. This is called an A record, and it just maps the name DB to our server's IP address. And finally, we got to test it. We'll hope on another machine and make sure our new phone book actually works.
And just like that, success. From a client machine inside our private network, we can now reach our database just by using its simple, human-friendly name. We ask for db.internal.corp, and boom, we get a response straight from the correct server. Our private phone book is officially open for business.
Okay, but now we get to what I think is the most important lesson of all. Section 4, the sabotage. This is where we're going to see exactly why all those engineers love to groan and say, oh, it's always DNS.
I want you to really put yourself in this scenario. You have set up your private zone perfectly. Every record is correct. You're looking at your cloud dashboard and it is all green check marks. Everything looks absolutely perfect. But your application is timing out. It can't connect to the database. You are pulling your hair out. What could possibly be wrong? And here's the sabotage. The problem isn't in the cloud at all. It's a single line in a little local text file on the client machine itself. It's a file called /etc/hosts. And someone, maybe a developer running a quick test, who knows, has manually told this specific computer, hey, forget what the official phone book says. I'm telling you that db.internal.corp is really over at this other address, 1.1.1.1.
So what happens? Immediate failure. The application tries to connect to 1.1.1.1, which of course isn't our database, and the connection just times out. And meanwhile, you're back there staring at your perfectly configured cloud DNS, completely baffled, thinking you're losing your mind.
And this, my friends, is the crucial, critical lesson, the name resolution order. See, before your computer ever bothers to ask a real DNS server out on the network, it checks that little local/etc/hosts file first. It's like having a sticky note on your monitor that says mom's new number that you'll always read before you even think about opening your contacts app. That local file is the ultimate override, and it is the source of countless hours of painful debugging for engineers everywhere.
So let's do a super quick recap of the big ideas. An A record is just that basic phone book entry. Name maps to an IP address. A private zone is the phone book itself, but one that only exists inside your private network. Split horizon is that really powerful idea that the truth about where something is can be different depending on whether you're inside or outside the network. And the big one, the resolution order. Your computer always checks that local file first.
So I'm going to leave you with this question. The next time an application goes down and everyone is blaming the network, and you've checked your cloud DNS a dozen times and you just know it's perfect, where are you going to look first? Now you know. The answer probably isn't in the cloud at all. It's right there on the client machine itself.